Hi everyone, this is Group28. Our project focuses on analyzing social media discussion about Australia housing and cost of living crisis. Before we dive to system demo, let's quickly introduce our team. Ian is responsible for setting up the cluster environment, managing Elasticsearch data pipelines. Yang, which is me, implied the NLP processing pipeline. Yuhong focused on front-end development and visualizing key data insights, and Ling handled the API-based data collection and contribute to visual analytics. Over the past few weeks, we've developed and deployed a cloud-based data analysis platform that collects, processes, and analyzes large-scale social media data from platform Reddit and Mastodon. By doing so, we aim to uncover what everyday Australians are saying about housing topic online, their concerns, frustrations, and expectations. In today's demo, we'll talk through the core feature of our system and highlight how we use cloud computing and techniques to track and analyze public discussion around Australia's housing issues.
Let me now explain how data flows through our system. First, our data fetchers collect posts from Reddit and Mastodon based on housing-related topics. These posts are indexed into Elasticsearch, which basic metadata. Next, the NLP processor enriches this data by analyzing sentiment and extracting location information, updating data in Elasticsearch. Finally, our API endpoints query this enriched data, performing aggregation that transforms individual posts into meaningful analytics. This pipeline runs continuously, with real-time data flowing in through scheduled harvesters and being processed and analyzed automatically.
Next, I'm going to introduce the architecture. So based on the graph, you can see we have different components within the Kubernetes cluster, which is set up, which is provided by MRC. So firstly, for external API, we use Reddit and Mastodon API. And in the data collection, we have 71 cron job that runs 71 topic for fetching the post within Reddit and Mastodon. Next, the data will be passed to Elasticsearch as our database, and then the NLP will process the post and then convert to the data form that we can use. And then we use the API to pipe the data to front end for the end user to view the data. So I'm going to give a detailed breakdown of the data collection layer. First, we have the source from Reddit and Mastodon, which we search and we search by subreddit with Australia, and Mastodon filter by Australia. And as I mentioned, we have 71 Kubernetes cron job, one per keyword per topic, and we evenly run this cron job within an hour. So every hour, each topic will be run once. The Python collector will handle paging and rate limit and retry. And then we batch update the NLP process data to Elasticsearch per job. So currently we have a data set of over 330,000 posts. Next, the storage layer. The Elasticsearch database optimized for unstructured text analysis, and we have a custom Sigma designed for supporting sentiment and geographic queries. We have the horizontal scalability for growing dataset. It will automatically be scaled up and down. And we have the powerful aggregation framework for complex analytic, which will be used for API point.
Yeah, I'll continue introducing the NLP component of our project. Our pipeline mainly focuses on three key tasks: text cleaning, location extraction, and sentiment scoring. It is implemented as one script, and all the processing results are written directly to our Elasticsearch index for downstream analysis and visualization. First, we clean the raw text by removing things like punctuation, emojis, and control characters. This step ensures that what we feed to later modules is consistent and easier to work with. Next one is location extraction. We use a rule-based method to detect city and state names. We match the tags assigned a structured location directions based on the official ABS datasets. When there is no match, we just simply return as unknown. For sentiment analysis, we use text block. It's a lexicon-based tool that gives us a score between -1 and 1. We then scale that to 0 to 10 range to make it easier to visualize in our dashboard. And the score closer to 10 means more positive, and closer to 0 means more negative. Finally, the pipeline runs in batches and skips any posts that have already been processed, which keeps the things efficient. It wraps in efficient functions so it can run on a schedule or be triggered automatically.
Next, I'm going to introduce the API layer. So mainly we have 4 APIs that's used for front-end to show. The first one will be the monthly trend, which shows the latest 12 months time series analysis of post. And next we have the sentiments extreme, which have the top and lowest, highest and lowest sentiments of the 3 cities. Next we have the state distribution, which break down by geographic, by state or territory. Finally, we have the weekly count, which counts the posts of past 7 days and aggregate by the calculate the average sentiment. And then comes to the front end layer. For the front end, we have Jupyter Notebook as the dashboard of interactive visualization. And of course, it's hosted on Kubernetes with customized configuration. And then we had the API for data retrieval for front-end to retrieve data. And then finally, we use Matplotlib to provide a visual analytic. So for fault tolerance, we have 71 separated data collectors. So even if one of the topic fail, the other will continue to run. Next is the component that's being separated. So if problem happens in one component, it won't affect to the other part. Next, within the code, we have some safety setup. We use backup value, like default value, instead of just crashing the code. For example, for NLP processing, if anything happened to when we evaluate the sentiment or location, it will just set to a default value like -1 or unknown. Automatic recovery is part of the function that provided by Kubernetes. The system will restart when breakdown happens. For data backup, we have multiple copies of data that can prevent information loss, even if one of the data images that's down. Next, we have graceful operation. The whole code base is fault tolerance, which we have try an exception for system to continue to run without crashing. Next is the scalability. So because we're using Kubernetes cluster, we can simply add more worker nodes if we need more computing resources. Next, workload distribution. We have 71 topics spread across the timeline to balance the load, so it won't be too much pressure for the API that we call. Next is the Elasticsearch sharing. The data distribute across multiple nodes for the Elasticsearch that we set up. And then serverless efficiency. So we decide to use Fission to set up the serverless function. So the resource will be allocated only when the function is executed. This will help us to save the computing resource that we use. Finally, we have batch processing especially for NLP component that we handle data and write back to Elasticsearch in batch size. So in this case, data will be processed more efficiently.
And now I'll introduce the 4 core analysis functions we implemented to explore public sentiment. Each designed to highlight the different aspects of how emotions shift over time across locations and in response to current events. And the first one is the monthly trends. It analyzes the total number of posts and average sentiment score for each of the past 12 months. This function helps identify long-term sentiment trends, seasonal fluctuations, and sentiment shifts during specific periods. And the next one is regional distribution by state. It aggregates total post count and average sentiment score by state. This function reflects user sentiment and activity levels across different geographical regions. And the next one is sentiment score extremes by location. It selects the top 3 and bottom 3 cities based on average sentiment scores. This function helps identify areas with concentrated positive or negative sentiments, supporting regional responses and sentiment monitoring. And the last one is weekly sentiment distribution. It analyzes the daily post counts and the distribution of sentiment scores across defined score ranges over the past 7 days. This function helps track short-term sentiment fluctuations and the immediate impact of training events. Together, these 4 functions provide a comprehensive view of sentiment across time and space, from identifying long-term emotional trends to spotting sudden shift or regional sentiment clusters. The system enables deeper understanding of user behavior and offers valuable insights for monitoring public opinion and guiding response strategies.
So before ending, I'm going to give a short demo of our data on Kibana, using Kibana on Elasticsearch. So from the table, you can see we have over 330 hits, which is the post that we have. And yes. And for the front end, here you can see I'm visiting from localhost 888 because I do pull forward here. So to view it, you run a port forward, forwarding the port from Kubernetes to your local machine, and then now I can visit it with 888. Yes, and then just to prove its function, I'm going to run it. This import the necessary library, and then the first data analysis, the second one, the third one, and the final one. Yes, and thank you for watching. Yeah, thank you for watching, and yes.